Hi everyone, we're going to work on the second part of the review for exam 3. Question 17 is asking us to use the remainder theorem to find the remainder when f of x is divided by x plus 4 and then decide if this is a factor of the function or not. So one way is to divide this function by x plus 4. I can use synthetic division, and if the remainder is 0, that means the function is divisible by x plus 4 and x plus 4 is a factor. But another easy way to do that is just use this remainder theorem, which is saying that if I set x plus 4 equal to 0 and then solve for x equal to negative 4, if you find f of negative 4, if f of negative 4 equal to 0, that means the function is divisible because f of negative 4 is basically the remainder of dividing this function by x plus 4. So I'm going to find f of negative 4. That is 4 times negative 4 to the power of 6 minus 64 times negative 4 to the power of 4 plus negative 4 to the power of 3 minus 4. And when you calculate, that is equal to negative 68. Negative 68 is the remainder of the function when it's divided by x plus 4. It's not 0, so it's not divisible. That means x plus 4 is not a factor of the function. We're going to do the same thing here. Instead of dividing the function by x minus 1 over 6, you set x minus 1 over 6 equal to 0, and x is equal to 1 over 6. Now find f of 1 over 6. 6 times 1 over 6 to the power of 4 minus 1 over 6 to the power of 3 plus 12 times 1 over 6 minus 2. When you calculate that, it's going to be equal to 0. So remainder is 0, the function is divisible, and this is a factor of the function. Next question asked us to use the rational zero theorem to find the potential rational zeros. To find the answer, you need to find the factors of the constant term and divide by factors of the leading coefficient. You don't need to consider the negative, just the actual number. Factors of 5 are 1 and 5. 25 is 1, 5, and 25. Now you need to consider positive and negative of all those answers. Now start dividing. 1 by 1 is 1. 1 by 5, 1 by 25. 5 by 1, 5 by 5, and 5 by 25. Make sure you cross out the ones that are repeated. 5 divided by 5 is 1, which is repeated. 5 divided by 25 is 1 over 5, which is repeated. So we don't need those. So these are the answers, but consider positive and negative. So this will be the answer. Next question, again, we're going to do the same thing. Find the factors of 20 and factors of 2 and divide them. Factors of 20 are 1, 2, 4, 5, 10, and 20. Factors of 2 are 1 and 2. So divide 1 by 1, 1 by 2, 2 by 1, 2 by 2, 4 by 1, 4 by 2, 5 by 1, 5 by 2, 10 by 1, 10 by 2, 20 by 1, and 20 by 2. Cross out the ones that are repeated. 2 divided by 2 is 1. 4 divided by 2 is 2. 10 divided by 2 is 5. 20 divided by 2 is 10. And consider positive and negative of all those. So this will be your answer. Next question. We're trying to use rational zero theorem first to find the possible zeros of the function. But then we're going to find out of all those possible ones, which ones are really a zero of the function. And then we're going to use that to write the f of x in the factored form. So I'm going to start with this. Find factors of 5 and divide by factors of 25. So it's 1 and 5, and then 1 and 5 and 25. And the same way that we did already here on top, we're going to do the same thing. I'm not going to repeat that. So the possible zeros will be positive and negative 1, 1 over 5, 1 over 25, and 5. So now I need to decide out of all these possible ones, which ones are really a zero of the function. So based on what we did here on top, we're going to just find f of each of these numbers. If it's equal to 0, that means that number is a zero of the function. So I'm going to try f of 1. What is f of 1? It's 25, 1 to the power of 4. Plus 26, 1 to the power of 3. Plus 126, 1 to the 2. Plus 130 times 1 plus 5. When you calculate, this is going to be equal to 312. It's not 0, so 1 is not a zero of the function. Now, this time, let's try negative 1. So 25 times negative 1 to the 4 plus 26 negative 1 to the 3. 126 negative 1 to the 2. 130 negative 1 plus 5. And this time, this is equal to 0. So if it's equal to 0, that means negative 1 is a zero of the function. So x minus negative 1 is the factor that created the 0, which is x plus 1. This is one factor of my function. Now, I need to find the other factors of the function. What do? This is where I need to use synthetic division. So I'm going to use synthetic division to divide the function by this negative 1 again. So this is going to help me find the other factor of the function. How? So I'm going to write negative 1. This is my corner number, and list the coefficients, which are 25, 26, 126, 130, and 5. Okay, bring 25 down, multiply by negative 1. It's negative 25. Add by 26 is 1, times negative 1 is negative 1. 125 times negative 1 is negative 125. Answer is 5. 5 times negative 1 is negative 5, and it's equal to 0. So this is just going to confirm that, yes, negative 1 was a zero of the function. But I'm going to use the rest of these numbers to find the other factor of the function. How? This is the constant term. This is coefficient of x. This is coefficient of x squared, and this one is coefficient of x to the 3. So one factor was already, as we talked about, that x plus 1. The second factor is 25 x to the 3 plus 1 times x squared plus 125 times x plus 5. Now, am I able to factor this more? Yes, I'm going to factor this again. This is going to help me find the other zeros and also the other factors of the function. So let's see how I can factor this. I see that I can, I have 4 terms, so I can put them in groups, and in each group I have something in common. So between these two, x squared is in common, so I write 25x plus 1. Between these two, 5 is in common, so this will be 25x plus 1. And 25x plus 1 is the common parentheses here. So I factor that out, and I'm going to have x squared plus 5 left. And I already had an x plus 1 here as the previous factor of the function. So this is the factored form of the function, which I can write that here. What are the other zeros? So we already found one of them, which was coming from here, and it's negative 1. This is 1 0 of the function. The other one is coming from this one. So if I set 25x plus 1 equal to 0, x is equal to negative 1 over 25. This is the other zero of the function. And you see, it's already in the list that I had made before. And how about the last one? If I set x squared plus 5 equal to 0 to solve for x, x squared will be equal to -5, and then I have to take the square root of that, and I have a negative on the radical. So as you have learned before, the answer will be plus and minus 5i, but this is an imaginary root. The question is asking us to find the real zeros, not the imaginary ones. So that means we can just write -1 and 1/25 as the roots. And how do I write the factors here? Make sure when you're writing the function in the factored form, make sure there is no coefficient other than 1 here. So that means to write the factor, I'm going to write x plus 1 and x squared plus 5 here. The coefficients of those two are 1, the leading coefficient. But for this one, I'm going to factor 25 out. So if I factor 25, this will be x, and the other one will be 1/25. So this is the function that you need to write as the factored form. Okay, next question. Again, we're doing the same thing. We are going to use the rational zero theorem first to find the possible zeros, and then decide which ones are the real zeros of the function. I'm not factoring this function to find the zeros because it's not possible to factor that. So I cannot put them in group and factor. So I have to use the rational zero theorem. So I'm going to use factors of 5 and then factors of the leading coefficient, which is 11. So those are 1 and 5, 1 and 11. So the possible zeros will be 1, 1/11, 5, and 5/11, and I need to consider positive and negative. Now, how do I know which ones are really a zero of the function? As we talked about this before, I can find f of 1, so that's going to be 11 times 1 to the 3 plus 17, 1 to the 2 minus 21 times 1 plus 5. When you calculate, this is going to be equal to 12. It's not equal to 0. That means remainder is not 0. So 1 is not a zero of the function. Let's try -1. What is f of -1? It's 11 times -1 to the 3 plus 17, -1 to the 2 minus 21 times -1 plus 5. This is also going to be equal to 32. So this is also not a zero of the function. Let's this time try another one. I'm going to try 5/11. F of 5/11. It's 11 times 5/11 to the power of 3 plus 17 times 5/11 to the power of 2 minus 21 5/11 plus 5. This time, the answer will be equal to 0. When you use your calculator, you will see this is equal to 0. So that's a zero of the function. Now, how do I find the other zeros? I'm going to use synthetic division and divide this one more time to find the other factor, because right now, when this is the zero of the function, that means x minus 5/11 is 1 0 of the function. So how do I find the other one? So I'm going to use synthetic division. Write that again. So 5/11, this is my corner number, and list the coefficients: 11, 17, 21, and 5. 21 was negative. Then bring 11 down. 11 times 5/11 is 5. Add them. 22 times 5/11 will be 10. Add them, it's -11 times 5/11 will be -5 and equal to 0. So as you see, we found that before, that the remainder is 0. Here also confirms that remainder is 0, but now this is going to help me find the other factor. This is the constant term, coefficient of x to the power of 2. So my factors will be x minus 5/11 and 11 x squared plus 22x minus 11. Now I'm going to factor this. First of all, I can factor 11 out because it looks like everything, all the three terms have 11. I'm going to write the x minus 5 over 11 and write the 11 outside of that, x squared plus 2x minus 1. Now, can I factor this? Can I find two numbers that add up to 2 and multiply to 1 times negative 1? No. So I have to use the quadratic formula, which is x equal to negative b plus and minus b squared minus 4ac divided by 2a. So x will be negative b, which is negative 2. I'm going to write that here. Negative 2 plus and minus b squared is 2 squared, that's 4 minus 4 times a, which is 1, times c, which is negative 1, divided by 2 times a. And then when you calculate that, this is going to be negative 2 plus and minus. This is 8. Square root of 8 is 2 root 2 divided by 2. Now simplify. 2 divided by 2, this divided by 2, this divided by 2 will be negative 1 plus and minus root 2. So this is how I can find the other roots of the function. So the roots will be 5 over 11, negative 1 plus root 2, and negative 1 minus root 2. Okay, next question. We Nona paid $185 for a lifetime membership to the zoo, sorry, so that she could gain admittance to the zoo for $1.35 per visit. So she already paid $185, and now each time that she goes to the zoo, she's going to pay $1.35. So each time, let's call that X, and she's paying $1.35 each time. So basically, whenever she goes to the zoo, the total cost that she has been paying to visit the zoo will be this. This is the total cost. Now it's asking what is the average cost, because she has visited the zoo for X times, so you're going to divide it by number of the visits, which is X. So this will be the formula that you need to write here. Now it's asking what is her average cost per visit when she visited the zoo for 185 times. Well, in this case, X is 185. So just replace that here in this equation. When you replace, and then it's going to be equal to 185 plus 1.35 times 185 divided by 185. And when you calculate, that's going to be equal to 2.35. Now, it's asking us to find the graph of the function. Look at this function that we have here. I see that I will have a vertical asymptote at x equal to 0. Why? Because to find the vertical asymptote, you set the denominator equal to 0. So this is x equal to 0. That's my vertical asymptote. What is the horizontal asymptote here? Since degree of the top is 1, degree of the bottom is also 1, so the horizontal asymptote will be leading coefficient of top, which is this, over leading coefficient of the bottom, which is 1. So it's 1.35. So I know that I have a rational function. So this is not the graph of the function. It should be one of these two. Which one has x equal to 0 as vertical asymptote? Both of them. Which one has this as horizontal asymptote? That's this one. Now it's asking what happens to her average cost per visit if she starts when she's young and visits the zoo every day. That means the number of the visits are growing, are getting bigger and bigger and bigger. And this is what is happening when the x value basically is growing, the value of the function is getting closer and closer to the asymptote, which was 1.35. So this is the answer. Question 24 is asking us to find the complex zeros of the function and also write that in the factored form. Okay, so first of all, I look at this function, see if I can factor this or not. This is a perfect cube. This is also a perfect cube because x to the 3 is x times x times x. 125 is 5 times 5 times 5. So I can use this identity that you have learned that before. A to the 3 minus b to the 3 is equal to a minus b times a squared plus ab plus b squared. Okay, so I'm going to use that identity. So a is cube root of x to the 3, which is x. B is cube root of 125, which is 5. Now a squared is x squared. A times b is 5x, and I put a plus here, and plus b squared, which is 25. So I found one factor of the function, and this one is the other factor, but can I factor this more? Let's see. Do I have two numbers that I add them, I get 5, and multiply, I get 1 times 25? No, I can't. So I cannot factor this anymore. Now I need to find the zeros. Of course, one of the zeros is 5 when you said x minus 5 equal to 0. To find the other one, I have to use the quadratic formula. Again, I'm going to write that here. Negative b plus and minus b squared minus 4ac divided by 2a. Okay, so x will be negative b, which is negative 5, plus and minus the square root of b squared is 25 minus 4 times a, which is 1, times c, which is 25, divided by 2 by a, which is just 2. So that's going to be negative 5 plus and minus. On the radical, this will be negative 75 divided by 2. Now, what is negative 75 on the radical? So I'm going to write that here. 75 is basically 25 times 5. So if it's on the radical, it's going to be square root of 25 times 5, and 25 can step outside of the radical as a single 5. So I can write that as negative 5 plus and minus 5 square root of 5. However, there was a negative. I don't forget about that negative. I'm going to put that here, divided by 2. And we know that if we have a negative on the radical, you can change it to I, because let me explain this to you here. Negative 5, I can write as square root of negative 5 plus square root of 5. This is I. So I can write I root 5 instead of that. So the answer is negative 5 plus and minus 5i root 5 divided by 2. So these are the two roots of the function. I can separate them and write as 5 over 2 plus 5 over 2 I root 5. And the other one will be negative 5 over 2 minus 5 over 2 I root 5. These are the roots of the function. So I'm going to highlight them. These are the ones that you need to write here. I also need to write the 5. And I just figured out that I made a mistake, because 75 is 25 times 3. So this is 3. And right here, I'm going to write 3, 3, 3, and 3. Okay. So the zeros are these two numbers. It's asking us to write only the complex zeros. So I guess probably you don't need to write the 5 as a 0, just need to write these two. You can try it and see what it's basically asking you. Anyway, and now I'm going to write the function in the factored form, which is going to be x minus 5 and then x minus negative 5 over 2 plus 5 over 2 I root 3 and x minus negative 5 over 2 minus 5 over 2 I root 3. I'm going to leave the rest of that for you to just distribute the negative and calculate the final answer when it's simplified. Okay, now let's work on next question. Again, we want to find the complex zeros. I cannot factor this function, so I have to use the rational zero theorem. So factors of 106. So let me find factors of 106 and also factors of the leading coefficient, which is 1. So factors of 126 are 1, 2, 53, and 106. Factors of 1 is just 1, plus and minus. So these are the possible zeros of the function. Now, which ones are really acceptable as a zero of the function? So I have to try the remainder theorem again. So I'm going to try f of 1 to the power of 3 minus 6 times 1 squared plus 61 times 1 minus 106. And the remainder the answer of f of 1 will be negative 50. So this is not a zero of the function. Now I'm going to try another one, f of negative 1. That's negative 1 to the power of 3 minus 6 times negative 1 to the power of 2 plus 61 times negative 1 minus 106. This time, f of negative 1 is 0, so that means negative 1 is a zero of the function. So what I'm going to do here is, again, use the synthetic division to find the other factor of the function. So negative 1, and I list the coefficients, negative 6, 61, negative 106. Bring the 1 down. 1 times negative 1 is negative 1. This will be, and sorry, I figured out that again I made a mistake. It's just so many calculations, I can easily make mistakes. But anyway, this was f of 2. F of 2, when you calculate, it's equal to 0. So 2 is the 0 of the function. Now I'm going to divide by x plus 2, x minus 2, use the synthetic division. So 1 bring down times 2 is 2, plus negative 6 is negative 4. This will be negative 8, and it's equal to 53 here, times 2 is 106, and it's 0. So the remainder is 0. Yes, f of 2 is equal to 0. That confirms that. So that means 2 is the 0 of the function. Now, what is the other factor of the function? I know the first one was x minus 2. What is the other one? That's going to be 1 times x to the power of 2 minus 4 times x plus 53. So these are the two factors of the function. Now, am I able to factor this more? Can I find two numbers that add up to negative 4 multiplied to 53? No. So I have to use the quadratic formula to find the other zeros of the function here. So when you use quadratic formula, the other zeros will be 4 plus and minus the square root of negative 196 divided by 2. So when you simplify, we know that 196 is basically square of 14. So this will be 4 plus and minus 14. And since I have a negative on the radical, so it's going to be 14i divided by 2. You can simplify by dividing everything by 2. So that's going to be 2 plus and minus 7i. So these are the other zeros of the function. These are the complex zeros. So you're going to write them here. And the factor form of the function will be, I'm going to write that here, x minus 2 times x minus 2 plus 7i and x minus 2 minus 7i. Now I'm going to simplify that. X minus 2 is already here. Distribute the negative. This will be x minus 2 minus 7i. And here distribute the negative. It's going to be x minus 2 plus 7i. Question number 26. Again, to find the complex zeros, I need to factor, but I cannot factor this, so I have to use rational zero theorem. So you need to find factors of the constant term, which is negative 75, and then factors of 1. So the answer will be plus and minus. Factors of 75 is 1, 3, 5, 15, 25, and 75. Factors of 1 is just 1, so this will be the list of all the possible zeros of the function. Now I'm going to check, see if these are really a zero of the function or not. So I'm going to try with 1. F of 1 will be 1 to the power of 4 plus 2 times 1 to the power of 3 plus 22 times 1 squared plus 50 times 1 minus 75. And when you calculate, it's going to be equal to 0. So this time we're lucky that the first number that we tried is the zero of the function. I'm going to use synthetic division again to find the other factor. So list the coefficients 1, 2, 22, 50, and negative 75. Okay, bring the 1 down. 1 times 1 is 1. This is 3 times 1 is 3. Add them 25, 25, add them 75. Multiplies positive 75 is equal to 0. So this is the remainder. So one of the factors is x minus 1. The other one will be, this is the constant term, coefficient of x to the power of 2, and x to the 3. So the other factor is x to the 3 plus 3x squared plus 25x plus 75. Now, can I factor this more? Yes, I can put these in groups. And here I'm going to factor x squared. So I will have x plus 3 left. The second one I can factor 25 and x plus 3 will be left. Now factor x plus 3. I will have x squared plus 25. The other factor was already x minus 1. Now, what are the zeros of the function? If I set this equal to 0, x is equal to 1, which we already found that before. This one set equal to 0, x is equal to negative 3. But this one, when I set that equal to 0, x squared plus 25 equal to 0, subtract 25, x squared will be negative 25, and then I take a square root of both sides. So I will have x equal to plus and minus square root of negative 25. The square root of 25 is 5, but the square root of negative 1 is equal to I. So the complex zeros are positive and negative 5i. And what is the factored form of the function? You're going to write x minus 1, x plus 3, and for this one, you're going to write x minus 5i and x plus 5i. This is the complete factored form of the. Okay, last question. We want to form a polynomial that is a degree of 4, and the zeros are this one and 3. The 3 has multiplicity of 2. So first of all, I'm going to take care of that. So if I have a 0 at 3, that means I have x minus 3 as a factor of the function. Multiplicity is 2, that means the power of this factor is 2. Then this one, if I have a 0 at negative 2 plus 2i, I'm going to have this factor x minus negative 2 plus 2i. This is one factor. However, if you have a complex 0, you always will have the other 0 as this way. So one 0 is this, the other one will be negative 2 minus 2i. This is called the conjugate of this complex number. So if you have a complex number as a 0, the conjugate of that will also be a 0 of the function. So I'm going to write x minus negative 2 minus 2i. So this is the factored form of the function. Now I have to distribute all these and then find a simplified form. Okay, so x minus 3 to the power of 2, if you calculate that, you will see that it's going to be x squared minus 6x plus 9. Just multiply x minus 3 by x minus 3 and distribute. This one, I'm going to write this as, when I distribute the negative here, it will be x plus 2 minus 2i and x plus 2 plus 2i. So look at this. X plus 2, x plus 2, negative 2i, positive 2i. This is basically a minus b times a plus b, which is just a squared minus b squared. So this will be x minus 2 squared minus 2i squared. Okay, what is x minus 2 squared? X minus 2 squared is x squared plus 4x plus 4. And 2i squared is 2 times 2 is 4. I to the power of 2 is I squared. We know I squared is negative 1, so this is negative 4. And I had a negative here as well. So negative times negative 4 makes it positive 4. And the first parenthesis was already x squared minus 6x plus 9. So I'm going to simplify again. X squared minus 6x plus 9, and here x squared plus 4x plus 8. Okay, now start distributing all these. X times x squared is x to the power of 4. X squared times 4x is 4x to the 3. Times 8 is 8x squared. Now, negative 6x times x squared is negative 6x to the power of 3. This time, this one will be negative 24x squared. Negative 6x times x, negative 48x. And now 9 times x squared is 9x squared. 9 times 4x, 36x. 9 times 8, 72. When you simplify and combine the like terms, this is what you're going to have. X to the power of 4, and then the power of 3's will be negative 2, x to the 3. The power of 2's are these 3. When you combine, it's negative 7x to the power of 2. And the power of x's are these 2, which is going to be negative 12x, and the last one is 72. 72. So this is my polynomial, but remember that there was a leading coefficient of a here. We don't know what is a, so when you're trying to write, all you need to do, the a is already here, you just need to write this part. Okay, so this was the second part of the test. I hope this was helpful for you.